The recording has been started. So today we are going to see a new topic which is called as polymorphism. Okay. This is one of the important topics in core Java. So even in developing the real-time applications, we often come across this polymorphism concept. So please pay some attention here. Let me describe you, or let me give you some demonstration about polymorphism. Okay, the word itself says, okay, poly means poly actually means many. Okay, morphs means many forms. Okay, I can say that polymorphism is nothing but the many forms. One thing, if you take one entity, if one entity existed in many forms, you call it as polymorphism, right? So what does it really mean is, it's very simple. Let us say that there is a person. Okay, let us say that there is a person, and the name of the person is something like Ganesh. Right? So the identity of this person is Ganesh, right? But if you just if the Ganesh visits office, okay, even though the identity remains same, but if he visits office, he would be recognized like an employee, right? He is an employee to the office, even though the identity is going to remain the same, but he will be recognized as an employee, right? And if the Ganesh is visiting the supermarket or any restaurant, right, he would be recognized as a customer, right? If the Ganesh is visiting the railway station, he would be recognized as a passenger, right? Likewise, if the Ganesh is visiting his house, okay, so in his house he would be recognized as a son, right? He is a son for his parents, right? Likewise, if the Ganesh is visiting a temple, okay, he would be recognized as a pilgrim, right? If the Ganesh is visiting any places, okay, so there is a kind of recognition for this Ganesh. Wherever he visits, he is getting a different identity. So I can say that this one person is existed in many forms, depends upon the location that he choose. Office employee, even though the name is going to be same for all the locations, but the recognition is a bit different, right? The name is same. Okay, the name is same, but the recognition is bit different. Okay, the office employee, customer, and in the railway station is passenger, temple pilgrim, and in the to his parents he is going to be what, he is the son to his parents, right? This is nothing but polymorphism. So this is the real-time analogy where we can conclude that Java polymorphism is the thing exactly what I have just explained. This is what the polymorphism is, right? So let us convert this analogy to the real-time Java examples. So when I want to convert this analogy to the real-time Java examples, I can say that if one entity exists in multiple places, it is called as polymorphism. So you take an entity, if that entity is getting recognized in multiple places with different recognitions, it is called as what? It is called as polymorphism. So this polymorphism is categorized into two types further. Okay, polymorphism is categorized into two types. Okay. The first one is you have something like compile time polymorphism. The second one is runtime polymorphism. Okay. Let us understand what is this compile time polymorphism. Okay? So before understanding this compiling polymorphism, we need to understand a concept called the method signature. Okay, the method signature. What is a method signature? Okay. So to understand this, I want to take two classes. Okay, let me take a class. Okay? Let me take a class A. So in my class A, I'm going to take one method. Okay, method as m1. Okay, I'm taking another method as m2, which is accepting an argument. Okay, is accepting an argument. Okay, I'm taking the third method as m3. Okay, which is accepting two different arguments. So d no int b. Right. So the method signature is combination of the method name plus the parameters. So this is called as one method signature. The method signature is the method name followed by the parameters. This method signature is method name followed by the parameters. If I ask you how many method signatures are there, I can say that there are three method signatures. Okay, these are the method signatures. Okay, you just take the method name followed by the arguments. Method signatures. Right, you don't include the return type. Okay, the return type can be anything. It can be void, or it can be integer, it can be float, whatever it is. You do not consider the return type. All you consider is only the method name followed by number of arguments that it is accepting. In this case, there are no arguments, but still it is a method signature, combination of method name plus arguments. Method name followed by arguments. Can be no argument, it it may be taking some arguments. Okay, I can say that what is a method signature. So by this we got to know what is a method signature. It is a combination of method name along with the method argument. It is the combination of method name along with the method arguments. Okay, so I can say that it is used by the, okay, now you see, let me take a small program. Let me take, I have a class here. Okay, and I am going to take I think there is already a class here. Okay, let me take a class. Okay, inside my class I am just going to take two methods, void m1, okay, and void m2. Okay, this is accepting something like integer a, this is accepting something like float. Okay, let me take a simple system.out.println statement. Println, okay, int arg method. The logic that I'm writing inside the method is nothing but I'm just checking whether which method is getting it, if this particular method is getting executed or not. We are just trying to check the control flow, right? So in order to check the control flow, we are using the system.out.println statement, nothing else. It is not a rocket science logic, a very simple logic where we are checking the actual control flow. Okay. So I have two methods inside the class here, and I have the driver class. So totally I have two classes, and in the class A I have two methods, and in the class driver I have only one method, which is a main method. Right, now let us understand the importance of method signatures. Let's understand the importance of the method signatures. Now what I am trying to do is, let me create an object for the class A obj equal to new. Okay, I want to call the m1 as well as the m2 method. So if I want to call m1 method, I need to use a reference variable obj, right? We know these things already. I can say obj dot m1, right? And I need to pass something inside. But if I want to execute this method, what I have to do, I have to pass an argument. So method 1 is accepting an argument of integer type, right? So I want to call this method. If my requirement is to call this method, okay, this is the name of the method is m1, which is accepting an integer argument. I have to pass some value which is of integer type, 100, right? Satisfied. 100 is of integer type, so this method will get executed. Likewise, if I call method m2, right, and I need to, if I want to execute this method, I need to pass a value that is of floating type in nature, right? So let me pass 0 0. So because of this, what are the changes that you are going to see behind the scenes? Okay, it is not only about the execution. This is not the direct execution. There are so many things that will happen behind the scenes. Okay, what are the things that you are going to see? What are the things that is going to happen behind the scenes? Is pretty simple. Okay? I can say that there will be a kind of the method table will be created. Okay, now focus here. So you have the class A here, and you have another class driver here. Okay, so we know compilation will happen and the execution will happen. Okay, at the time of compilation, what will happen is a method table will be created. What will be created? A method table. Method table. Okay. This method table is going to store the respective method signatures. So you have the object is being created for the class A, right? So we know object will be created, right? With respect to class A, you are calling method M1 and M2, right? So under the class A, it will just store the method signature. The method table is going to store the method signature. So there is a method M1 and the signature of the method is what? Integer. Only this information will be stored by the method table. Right? There is a method M2. And the signature of this method will be stored inside the parameter. Okay? So this method table is going to store the method signatures. Okay? After this, what will happen? Okay, these things are happening during the compilation time. Okay, these things are happening during the compilation. At the time of execution, okay, object this this piece of line is going to create an object in the memory. The reference variable is going to be obj, right? After this, look at the second line, next line execution. You are calling m1, okay, on top of obj, right? Firstly, the control will try to map. Okay, so see, the method name is m1. They are passing a value which is integer in nature. It will check in the method table, is there any method signature, okay, with the method name m and the value integer. Okay? So this is same as this. This is same as this, isn't it? This is same as this. Right? Once it is identified, okay, the respective method will be executed. Okay, which is what this method will be executed. I will tell you why this method table is used. You will understand going forward. Why these method signatures are used. We will understand going forward. Okay. Likewise, in the second thing is, okay, so there is you are calling method m2 and you are passing the floating point value, right? Okay. So controller will check, is there any method signature by the name of m2 followed by what? There any method signature with the name of m2 and which is accepting the floating point value. Of course, there is a m2 method which is accepting floating point value, right? So the respective method will be called. This method will be invoked, right? And you get what? You get the int argument method in the console and float argument method as well. Okay, so this is not the actual idea about method table. The method table is going to help us in a different way. We are going to see that. Okay, what can I write here? It is a combination of method name along with the method arguments. It is used by the compiler to create the method calls. is to create the method table and the respective method signatures will be stored inside it. So that the method calls will become easy, gets executed smoothly in the runtime. Okay. Now the question is, now what will happen? Let me execute this piece of code. Okay, let me execute this piece of code. Java C space driver.java Java space driver. Okay, int arg method, float arg method. Now the question here is, so you're using a method signature, no? So this is the method signature and this is the method signature, right? What if I try to duplicate this? Okay. What if I try to do what? What if I try to duplicate this? Duplication in the sense, okay, let me take m1 here, integer a, and let me say integer b. Integer a and integer b, right? And if you see, I just want to call the m1 method and I'm passing a value like 10 here, right? So on top of our picture, you're calling the m1 method, and if you see, there will be a method signature in the method table, right? However, if you see, there are two identical methods. Okay, if you see, there two methods are having the similar method signature. Like this is the method having the same signature, and this is the method which is also having the same signature. So duplication has happened. You cannot duplicate the method signature. Even though if you make some changes to the return type, okay, let me say that this method is returning something like an integer. Okay, let me execute this. It says m1 int is already defined in the class. It will consider it as a duplicate. Okay, let me put this code for you. Okay. Always remember, you cannot duplicate the method signature. Why you cannot duplicate? So this is same. This is same. Method signatures are same. But both method signatures are same, isn't it? However, if you look at the return type is different. Return type is different. So this is not returning anything. It is returning integer value. No matter if you take a different return type also, no issues. But you should ensure that you are not duplicating the method signature. If you are duplicating method signature at the time of calling this method, you may be creating an object like a obj equal to new a, right? And you will be calling obj dot method one. Method one, you pass a value something like 110. So m1, there are two m1s, and also both m1 methods are accepting the same value, same type, both are having the same type. So I can say that basically both are having the same method signature. So it is a kind of duplicate, right? Duplicate method signatures are not allowed. Yes, not allowed. If you try to place a duplicate method signature, you will get this error. You will get the compile time error. I can say that. Please be informed that duplicate method signatures are not allowed, and if it is violated, you will get the below error. Okay. Now we have got some idea about what is a method signature. Okay, now we will understand what is method overloading. What this method overloading has to, so we need to understand, right? So I have said there is a compile time polymorphism. Okay, so let me say it is further. We are talking about the compile time polymorphism now. So to understand compile time polymorphism, we have tried to understand what is method signature. Now we got to know what is method signature. Now we'll understand what is compile time polymorphism. Again, this compile time polymorphism is further classified into or categorized into two types. First one is method overloading. Second one is operator overloading. So what is method overloading? What is method overloading? Okay, very simple. Let me go back to the same class. Okay, right. Now let us say that I have a method like void m1. So method name is m1. I have another method like void m1 which is accepting an integer argument. I have another method like void m1 which is accepting what? Float argument. Okay. And if you see, I have three different methods inside the class A. I have the method m1, I have the again I have method m1, again I have method m1. Method names are same, but each and every method is accepting different sets of argument. Even though the method names are same, they are accepting different sets of argument. In the arguments wise, they differ in argument wise. They are same when you consider the name of the method, but they differ in number of arguments. I can also say that every method has different method signature. Right? I can also say that every method is possessing or have the similar names, but their arguments are different. This is called as method overloading. This is called as what? This is called as method overloading. So system dot out dot println. So let me print no argument method. Int argument method. Okay, float argument. Okay. Let me bring this to the paintbrush. Now you see. Okay. So there is a method table. A method table will be created, right? So inside the method table is going to store the method signature. So m1 method which is accepting no arguments. Second one is again m1 method which is accepting an integer argument. The third method is m1 method, okay, which is accepting what? Which is accepting the float argument. Three different method signatures. So this is one, this is two, and this is three. Right? So they are stored in the method table at the time of compilation. Right? And the moment you start creating an object, a obj equal to new in the main method. Okay? So when you say obj dot m1, okay, so you are calling obj dot m1. So it will check is there any m1 method, is there any m1 method with the same signature. Suppose there is an m1 method with the same signature, right? Then this m1 method will get executed. Okay. Secondly, okay, obj dot m1, right? If you pass 100 here, okay, it will check is there any m1 method that is accepting the integer as an argument. Yes, it is there. M1 integer. The respective method will get executed. Likewise, if you say obj dot m1, right? If you say 100.0, floating, you pass floating point value, will check is there any method signature which is same as the method call. Yes, there is a method, then the respective method will call. You may be thinking why this method table is used. It can directly call now why this method table is used. That is the question, right? Now let me this is the concept of the compile time polymorphism. Okay. Now I will introduce you some cases where there will be an ambiguity. There will be ambiguity. So that ambiguity will be resolved with the help of the method table. Okay, we are going to see that. For now, this is how the call will happen. Okay. So these all three methods are called as what? The overloaded methods. All these three methods are called as what? The overloaded methods. What is an overloaded method? When you have the same method name in a class, when you have methods with the same name, okay, which have different, which are having different arguments, this is called as what? The method overload. What can I say? What is method overloading? Okay, when you have methods with the same name in a class, when you have methods with the same name but they differ in parameters, okay, they are called as overloaded methods. Okay. This mechanism called as method overload. Example, when you have a method like, let me say void m1 void m2. So these two methods are not overloaded methods. They are not overloaded because their names are completely different. Even though they have same parameters, their names are completely different in nature. Right? They are possessing a different names. So they are not called as overloaded methods. When I say void m1 void m1. Now can you tell me whether this is an overloaded method or not? When someone can tell me if this is an overloaded method or not overloaded?
Overloaded.
No, they are not overloaded because the method names are same and the arguments also same. So they are duplicate methods. Duplicate methods. Okay. So when the overloaded methods will come, when can I say a method is overloaded? When I say method name method m1. Now tell me, is it overloaded or not? Okay. This is overloaded methods. Why overloaded? Any two methods, any more than one method, if they are having the same name but different in argument. So this is accepting no argument, but it is accepting at least one argument. Argument wise they differ, but the method name wise they are similar. So they are called as overloaded methods. Are you able to follow? Yes, no?
Yes, sir.
Now it is called as, okay, method overloading is called as compile time polymorphism. Why it is called as compile time polymorphism means, okay, the method resolution will happen at the compile time. Method resolution will happen the compilation time, right? And that's why it is called as compile time polymorphism, or you can also call it as the early binding. Okay, there is a word called early binding or static polymorphism. What does it really mean? So method resolution will happen at the compile time. At the time of compilation, the compiler will get to know which method will be executed. Okay, when you look at this code, by looking at this code, compiler will get to know which method is going to get executed at the time of compilation time. It is going to know. It is going to get to know. This example, if you take this as an example, okay, and if you see at the time of compilation only, you will be keeping some code right here. Okay, you are going to call methods. At the time of compilation, it gets to know which method is going to get executed. That's why it is called as what? Compile time polymorphism. I will help you to understand the compile time polymorphism in a better way at the time of learning the method overriding concept. Okay, for now, What is compile time polymorphism? The compiler will recognize which method will get executed at the time of compile time only. No need to go to the runtime and see. Compiler will identify which method will get executed at the time of compilation time only. Right? And it is also called as, there are different ways you can call compile time polymorphism. What is a compile time polymorphism? Is nothing but the method overloading, or it is also called as the early binding, or it is also called as the static polymorphism. It's also called as what? It is also called as the static polymorphism. Okay. So having said this, let us do some case studies. Now you have to tell me the answer. We will do some case studies. Okay, and let me go back to the code. I have method m1 here. Okay. Now you have to answer me. Let me keep this very simple. Let me take only two methods here. Okay, a obj equal to new obj dot m1. Now tell me what will be the output if I execute this code.
Int argument method.
Int argument method, correct. Okay, so I can also execute the same method by passing different sets of argument, right? The output I will be getting what? Int argument methods for 3 times. So now you see int argument methods will be displayed for 3 times, right? Okay, now you tell me what happens if I just try to call. Now what will be the output? You can tell me.
Error, sir.
Error, definitely. Why error? I said no. You see incompatible price. Okay, compiler is scolding us. Compiler says you are passing a string, but there is no such method, which is such method which is accepting the string as the parameter, right? It is very straightforward. No explanation required, right? You are getting an error. Why you are getting an error? So now the actual concept, the method table is coming into the picture. How the actual usage of method table is coming into the picture. When you do this, definitely there is a method table gets created at the time of compilation, right? It is going to store the two method signatures. One is a simple m1 and the second one is simple m1, which is accepting the integer as an argument, right? But what you are doing, you are trying to do a manipulation, right? You are just trying to call the method m1 by passing a string, right? So there is no such signature here. There is no such signature here. That's why you are getting an error. Now you tell me what would be the answer.
Argument methods.
Why int argument methods? Justification. Why no argument methods?
Explicitly.
Okay, I will. Okay, good. Answer is correct only. Output is going to be what? Int argument methods. Okay, this is one of the popular interview questions. Int argument. I will tell you why it is int argument methods. Okay, now focus here. Okay, now you see. Let me create a table. Right, compiler will create two methods. I mean, the method table will have two method signatures. One is m1, second one is m1, which is accepting integer as an argument. Right, so this is called as what? Method table. Right? Okay. Isn't it? Okay. So now, so you are passing, okay, you are passing something like obj dot m1, and you are passing a character set of value, character value. Passing a character. C is nothing but the character. But C is nothing but the character. Okay. So The compiler will check is there any method signature that is accepting the character. So this is accepting no arguments and this is accepting int argument. Then compiler will not throw any error directly. What it will do, it will try to promote this character to the next level. Will try to do the promotion. I think you remember the promotion chart, right? Promotion chart will look like this. Okay, so there is a byte, the beginning, followed by short, followed by int, followed by long, followed by float, followed by you have double, isn't it? Double. Okay. And this is where the character is going to. Okay. Yeah. Right? Promotion chart, right? I hope you remember this. This is how the promotion will happen. So you are passing a character. Okay, the method signature say m1 comma m1 in the parameters you are passing a character, but there is no character. Right? Then the compiler will see is there any method that is accepting the integer. Compiler will promote the character integer. Right? And it will try to identify. Okay, promotion will happen. It will try to identify character is promoted to integer. It will try to identify is there any method signature of this integer. There is a matching method signature, right? So now this method will get executed. Able to understand what I am trying to say? So that's why the method table is used here. Are you getting? Hello? Yes, no?
Yes, sir. Yes, sir.
One more example. Try to answer this. Okay. Try to answer this. Let me take. I have something like float here. Okay. I am passing something like 100 point. So what would be the answer? You can tell me.
Int argument. Error, sir.
Why error?
We have to.
Okay. Good. Good. Answer is error only. Correct. I will tell you why error. Okay. Nice try. Possible. See what is happening. I am not passing float here. I am passing double here. Right? I am passing double value. You go by the promotion chart. Okay. If you just take this as an example. Okay. If you just create a method table. Okay. If you create a method table, you have what one method signature is here, and another method signature is over here, which is accepting the float error. Right. Two method signature. But here you are passing a value which is of double in nature. Double time. You are passing. This is what double. You are representing a double. M1 dot M1 double. So there is no double here. First of all, there is no double here. It will try to promote. It will try to promote. Okay, whether the double can be promoted or not. The problem is double can be promoted but can't be demoted, right? Can be depromoted, right? So the placeholder for double is actually the double is here. You can move this direction, but you cannot come back. You cannot do the depromotion. So there is a method. There is an available method which is of floating point in nature. Okay, but you are passing the double value. So you are trying to, the compiler will not depromote it to float and it will not execute that method. That's why this conversion is not possible. Making sense, everyone? Right? Only the forward direction is possible, not in the reverse direction. Okay, to make it simple, to understand this better, let me say I am trying to pass something like now tell me, is it possible or not possible?
Possible.
Possible, because you are passing float, even though float is not here. According to the promotion chart, okay, what will compiler will do? Compiler is going to do what? Okay, it will try to see you are passing float which is not even there, which is not there. Right? Passing a float value which is not there. Right? But it will promote to what? It will promote to double. It will promote to double. So double is there, so that gets executed. So double is there, that gets executed. So this checking will happen with the help of the method table. Right? Hope this is making sense. Right? One more popular interview question I will give you. If I try to answer this, I am taking the object here. I am taking the string here. String is object object. I am passing Java here. Can you tell me what would be the answer? I will give you the solid explanation for this. Let's try to this.
Argument only.
One guess, let me execute this. The int arg methods. Okay, you are getting this as an this is getting executed. Right? What is actually happening behind the scenes? Let me design the low level diagram. Okay, so there is a there is a string class. Okay, so there is a string argument and there is an object argument. Right? So here you are passing a direct. You are calling the method m1 and you are passing Java. Right? Definitely, this Java, this sequence of characters belongs to string, isn't it? The sequence of characters is belong to string directly. There should not be any doubts. This should get executed. There is a direct relation is there, right? The value that you are passing is getting mapped with the actual method signature. It is already there. Even though I place object or I place any other method, there should not be any confusions, right? Because that's why this is getting executed. What if you want to execute this? What if you want to execute this? When I want to execute this, for example, let me say something like, okay, instead of string, I am taking it as integer here. Now tell me what will be executed now.
Yeah.
Any idea?
Error only, sir.
Let me execute this. Hey, object method. Why object method? I will tell you. Why object method? I will tell you. I have already said, for every class, object is the super class of all the classes. This is object class, and you are using what? You are using you are passing the string. You are passing the string argument. Passing string argument. Right? For the string, object is a super class. So this is the promotion chart. For the primitive types, so this cannot be changed. For the primitive types, you know what is a promotion chart. This is the promotion chart for primitive types. But for the class level types, this is a promotion chart. Okay. If you are passing Java, and if there is no such method that is handling or that is accepting the string argument, okay, it will check is there any method that is accepting its parents argument, which is what? Which is object here. Object is a parent, right? Promotion will happen this way. Making sense? Promotion chart will happen this way. Right? Let me say, okay, if I want to execute this method directly, object method directly, even though I have a string here. String is string. If I want to execute the object method directly, I will pass the object. Let me say new object. That's it. This method will be executed. Object method will be. I am passing the actual argument here, new object. I'm passing the actual object. Actual object type here, new, which is what? Which is new object. Right? Now, if you see, now the object method will get executed. Right? So one more question. Let me pass null here. Null is what? No value. Null is something like no value. Let me pass null here. They pass null here. Okay. So this null is a value which is completely accepted by string. This null is a value which is completely accepted by object. Okay. So both methods are capable enough to handle this null value, and both the parameters are capable enough to handle null value. Right? If I just keep this piece of code, so let me execute this. See the output. Output will be string. String method. Okay, why string method? I will explain you now. Okay. So there is a method table. Okay, method table is going to have two method signature. One is m1 of object type. Okay, and the second one is m1 of string type. Two method signatures are there. Okay, but you are trying to call m1 method by passing null as an argument. Okay, so this null as an argument. Okay, this is also the matching method, and this is also the matching method. Why the priority is given to the method that is accepting the string argument? Always remember, the string is a subclass to the object class. This is an object class. Okay. This is the string class. For every class, object class is a superclass of all the classes. Okay. The priority will always be given to the child classes. Priority will always be given to the child class. That's why string method is this logic is getting executed. That's why the method that is accepting the string as an argument is getting executed. Even though this null is applicable for both the methods, there will not be any ambiguity issue. There will not be any confusion to the compiler. Compiler will say, okay, string can also accept null, and object can also accept null. Let me share this to the child. Let me give this to the child. Okay, that's why this child method is getting executed. Making sense? Right? Okay. So one more popular interview question. Just try to answer this. Teacher A, float B, float A, teacher B. Into float. So this is the popular interview question. Which method will be executed? Anyone?
Into float.
Int and float.
Okay.
Okay. Let us see. See what it says. Reference to method 1 is ambiguous. Because what the compiler is saying, both the method signatures are similar. Why it is saying like that? Let us understand. Okay. Now you see. Now this is where the method tables are. Method tables are considered to resolve the situation, ambiguous situation. So let me take a method table quickly. My method table has what? One is what? M1, comma, float, comma, integer. Second one is M1, comma, integer, comma. Okay. M1. You're calling M1, you're passing 10, comma 10. Definitely there is no doubt that you're passing 10 here. Right? So the matching first parameter, the matching has been found here. First matching parameter has been found here. There is no doubt. Okay. Secondly, you are passing 10 here. The second argument. passing 10 as a second argument, but the first matching argument is found here. According to the first matching argument, okay, so this is where the parameters are. Okay, forgot about the first matching argument. Let us say that we're passing 10 here, right? So the compiler has identified the first method which is capable enough to accept the 10 because integer, this is integer value which can be promoted to float also, right? So it is over here, right? The second argument is 10 again. Second argument is also 10, right? So let us say that, okay, the direct argument has been identified here. If you go through, if you do like this, 10 and 4, okay, so one argument is matching in the, I mean, one value is matching in the both the first parameters, both the first arguments in the both methods, in both of the methods. It is like a promotion chart is getting confused. Okay, how this is going to get promoted, that is getting confused. It's just like m1 comma, okay, if you pass 10, so this both can accept 10, even this float can accept 10, this integer can also accept 10. Again, if you pass 10 here, again this both can accept, this can also accept 10, this can also accept 10. The compiler will be in a confused situation, which method needs to get executed. There is no direct call here, because this is happening just because of the promotion chart. If there is no promotion chart, definitely output is going to be this one only. I mean, even if there is no promotion chart, there is no possible getting output. Since there is a promotion chart, there is a confusion here. Making sense? Both methods are getting validated because of this input values, right? So how I can break this validation? I can break this validation by doing what? If I do like this 10 comma, if I just specify here, one is integer, second one is float, definitely there is no issues. Int float, and again if I specify here, one is float and second one is integer, definitely there is no integer. If I am not specifying, if I pass two integer values, these integer values are capable to be handled by these two methods because of the promotion chart. One value is here, okay, and second value, because of the promotion, second value can be accepted. Likewise, first value can be accepted here because of the promotion, second value can also be accepted here. Both methods are getting validated because of these input values. That's why we're getting this error as what? Ambiguous. Reference to M1 is ambiguous. Confusion. It says both method M1 float and M1 is in a match. It says both are matching. Are you able to get what I'm trying to say? Everyone?
Yes.
Hello? Are you getting?
Yes, sir.
So this is one of the popular interview questions. So you, this is where it creates, the compiler get into a confused state because of the promotion chart. To avoid this promotion, to avoid this, you need to ensure that the exact values are passed, exact type is passed. If I remove this one method, definitely this is that. Now output will be this. If I keep two methods, okay, then there should be a kind of what? There is a lot of confusion happening. Right? So this is all about method overloading. What we have discussed so far, very simple. We discussed the what is polymorphism. Under polymorphism, one thing X is multiple, it is called as polymorphism. Okay, polymorphism categorized into two types: compile time, runtime. So before understanding compile time, we have understood what is method signature. Method signature is what? Okay, when you have the, will consider the method name and the parameters. Okay, the method name and the not the return type, only the method name and parameter. The combination of method name along with the method arguments is called as method signature. But why we have discussed about the method signature? To understand the compile time polymorphism, which is again categorized into two types: method overloading and operator overloading. What is method overloading? When one method, when the methods with the same name but different in arguments, they are called as overloaded methods. It is called as compile time polymorphism because the resolution will happen at the compile time. Compiler will decide which method will be executed. That's why it is called as compile time polymorphism. Right? So after completing method, operator overloading is already taken. This concept is already taken. Already taken during the initial classes. If you want, you can repeat that video. Only we have discussed about the plus operator overloading. Plus can be acting like an arithmetic operation as well as concatenation. Was discussed. So we will not be discussing operator overloading again. Not be discussing it again because I'm just mentioned there because it is under the compile time polymorphism. Okay. So tomorrow we will understand about method override. Okay. That's all from my side, guys. Thank you so much for attending. We'll see tomorrow.